Welcome to solverfy.
All right, so this time the recurrence relation is f of n is equal to 2 times f of the square root of n plus 1 when n is a perfect square and then f of 2 is equal to 1. And so part A wants us to find f of 16. Okay, so f of 16 is going to equal to 2 times f of the square root of 16, which is 4, plus 1. Okay, this is going to be equal to 2 times, so now we're going to put f of 4 in here, which is 2 times f of 2, right, the square root of 4, plus 1, plus 1. And we know f of 2, so now we can just calculate this. It's going to be equal to 2 times 1 plus 1 plus 1 is 7. Okay, so 7 is the answer for part A. But moving on to part B, it wants the big O estimate for f of n. So we're going to use the suggested substitution and let m be equal to the log of n, which is really the same thing as saying 2 to the power of m is equal to n. So now we can write f of n as f of 2 to the power of m. So that's going to give us 2 times f of the square root of 2 to the power of m plus 1. But this is going to be the same as rewriting it as 2 times f of 2 to the power of m over 2, right? Because square root is the same as being as the power to 1/2 plus 1. So that's just rewriting it. And now, for a little bit of clarity, we'll rewrite this function as g of m being equal to f of 2 to the power of m. And so what that means is g of m is going to equal 2 times g of m over 2 plus 1. Well, now it probably looks a little bit more familiar. And so we can use our master theorem with a is equal to 2, b is equal to 2, c is equal to 1, and d is equal to 0. So this is the master theorem. And if we consider the relationship of a and b to the power of d, we get that a is equal to 2, which is greater than b to the power of d, which is 1. So that means big O of g is going to be equal to big O m to the power of log b, so it's going to be log 2 of a, which is 2. Now, log 2 of 2 is going to be 1, and so this is really big O of m. We just have one little thing here. We don't actually want this in terms of m, right? So what this means is f of n is going to be big O log n, and we get that from our relationship that we started with, that m is equal to log